All right, let's dive in. Today we're looking at something pretty interesting in the world of language models. We're talking smaller language models, and specifically one called Hymba.
Yeah,
And you might be thinking smaller, what's the big deal?
right.
But the magic here is really all about how much performance they can squeeze out without needing, a giant supercomputer to run the thing.
Yeah, that's a great point. Himba is really tackling a challenge that I think a lot of experts in the field are thinking about, which is how do we balance the power that we see with these large language models with the need for them to be efficient enough to run on, a wider range of
So
devices?
it's about making them more accessible rather than just bigger and better.
Exactly.
Okay.
Think about it like transformers, which
Yeah.
are, kind of the big thing right now in language modeling. Those are incredible at remembering information, but they require a lot of computational resources.
Right.
But then you have these state space models, SSMs, which are super efficient, but they kind of struggle with tasks that require a lot of memory.
Okay, so we've got these two approaches, each with their strengths and weaknesses.
Right.
What makes Hymba different?
Himba doesn't just stack these two approaches on top of each other. It actually kind of weaves them together in a really unique way.
Okay.
So within each layer of the model, you have both attention heads, like you'd find in a transformer, and SSM heads working in parallel.
So it's getting the best of both worlds at every level.
Exactly.
So how does that work?
It's kind of like having a system with both a snapshot memory and a fading memory.
Interesting.
So the attention heads are able to capture very specific details like snapshots.
Okay.
And then the SSM heads kind of retain a more general understanding of the information over time.
Okay, so like how our memories, they fade, but we still kind of have the gist of what happened.
Exactly. It's a really elegant way to think about it.
That's cool. And I'm sure for all the LLM experts out there listening, they're probably thinking, okay, more attention heads. That usually means more memory requirements, right?
You're absolutely right. That's usually the case. But Himba actually gets around that by very strategically combining local and global attention.
Okay.
And what's really surprising is that they found that only 3 layers actually need that global attention to maintain the high level of performance.
Interesting.
The rest can rely on that more efficient local attention, and that really helps to keep the overall memory footprint much smaller.
So it's like having, express lanes for the most important information and then local roads for everything else.
I love that analogy. That's a perfect way to put it.
Okay, cool. And is there anything else that Hymba does to kind of keep things efficient?
Yeah, actually, they also use this technique called cross-layer key value sharing.
Okay.
And what that does is it reduces redundancy in how information is stored.
So it's like having a really organized filing system, no unnecessary duplicates.
Exactly.
Cool. Okay, well, switching gears a little bit.
Sure.
Can you tell me about these meta tokens I keep hearing about?
Yeah, these are really fascinating.
They sound like something straight out of a sci-fi movie.
Well, they kind of are. Essentially, meta tokens are these 128 learnable embeddings that get added to the input of the model.
Okay.
You can think of them as kind of like special tags that guide the model's attention to what's most important.
So instead of forcing the model to pay attention to absolutely everything, these meta tokens act like a cheat sheet.
Exactly. They're like, hey, pay attention to this. This is what's important.
That's really cool. And what's even more interesting is I hear that different meta tokens become active depending on the type of input it's processing.
Yeah, that's one of the most intriguing findings about them.
Yeah.
So, if you feed the model a news article, certain meta tokens will kind of light up. But if you give it a math problem, a totally different set will kick in.
Ah,
It's almost like these meta tokens encapsulate different types of world knowledge.
that's wild.
Yeah, it's really cool. And it seems to be playing a big role in how Himba is able to process information so efficiently.
So not only do these meta tokens help with efficiency, they also help to address this problem of force to attend, where the model's wasting computational power on irrelevant parts of the input.
Right.
So the meta tokens are kind of like a backstop,
Hmm.
allowing it to really hone in on what matters.
Exactly.
Okay, so I think I'm starting to see the bigger picture here, but can you walk me through what the Hymba attention map actually looks like?
Sure. So if you were to visualize it, you would see this really intricate combination of the meta tokens, the sliding window attention that we talked about earlier with the local and global attention,
Right.
and then the contributions from the SSMs.
Right.
It's this beautifully orchestrated system where all of these components are working together to really make the most of the model's resources.
Wow. And for the LLM experts out there, is this attention pattern something completely new, or how does it compare to what you see with like traditional transformers?
It's significantly different, actually.
Okay.
So in a vanilla transformer, you tend to see attention scores that are heavily concentrated at the beginning of the sequence.
Okay.
But in Hymba, the scores are much more balanced across the entire input, and that's thanks to these different components all working together.
So it's not just about combining two approaches, it's about creating a whole new way for these models to process information.
Exactly.
That's really cool. Now, you mentioned a Hymba family.
Yeah.
Can you tell me a little bit about the different models that they've developed?
Yeah, so there's the Hymba 125M, the Hymba 350M, and the Hymba 1.5B, and that refers to the millions of parameters that each model has.
Okay, and of course, the real test is how these models actually perform.
Right.
So what are the benchmark results showing us?
Well, this is where things get really exciting because Hymba is consistently outperforming other small language models in its size class across a wide range of tasks.
Like what kind of tasks are we talking?
We're talking text generation, question answering, code generation.
Wow.
It's really doing incredibly well.
That's really impressive, and I'm sure our listeners, especially those who are really familiar with the the LLM landscape, they're going to want some specifics. So what are some of the juicy details that you can share about how Hymba's performing?
Well, one of the most impressive findings is that Hymba 1.5B actually beats Llama 3.23B in accuracy.
Wow.
And this is despite being significantly smaller and faster.
Now, for our listeners who might not be, knee-deep in LLMs every day, why is that such a big deal?
So that means we're getting closer to being able to run really powerful language models on devices like your smartphone or even smaller embedded systems.
Wow.
So think about the possibilities, for things like personalized AI assistants, offline language translation, even advanced robotics that can really understand and respond to natural language.
That's mind-blowing.
Yeah, it's really exciting.
So Hymba could really be a game changer for making this technology more accessible to everyone.
Absolutely. And there's more.
Oh, there's more.
Yeah, it also performs remarkably well when it's trained only on publicly available data.
Okay.
And this is fantastic news for open source development because it means that researchers and developers can more easily build upon this work.
Open source is such a powerful driver of innovation, so that's really encouraging to hear.
Yeah, absolutely.
Okay, but what about those of us who want to use Hymba for very specific applications?
Right.
Can it be customized?
This is another area where Hymba really shines because it's extremely effective with these parameter-efficient fine-tuning techniques.
Okay.
So that means you can adapt it to very specific tasks without needing to retrain the entire model, which saves a ton of time and resources.
So we've got a model that's smaller, faster, outperforms larger models, works well with open source data, and can be easily customized.
Yeah, it's really hitting all the marks.
It's like hitting the jackpot for LM development.
It really is.
But I have to ask, are there any specific tasks where Hymba really stands out? Where it's able to tackle problems that other models really struggle with?
That's a great question. And one area where Hymba really excels is in what we call needle in the haystack scenarios.
Okay.
So this is where the model needs to find a very specific piece of information that's buried within a massive amount of text.
Yeah, that sounds like a real challenge.
It is. And, traditional transformers with their limited context windows, they often struggle with these types of tasks. And while SSMs are good at processing these long sequences of information, they can sometimes lose track of those really crucial details.
Okay.
But Hymba, with its hybrid approach, is able to kind of combine the best of both worlds.
So it's like having a detective with both a magnifying glass for those fine details and a wide-angle lens for the big picture.
I love that analogy.
And it makes me think back to those meta tokens that we were talking about earlier.
Right.
If they're already showing some specialization based on the type of input, what are the possibilities for the future? Could we see even more specialized meta tokens down the line?
That's a really exciting thought.
Yeah.
Imagine having meta tokens that are specifically trained for, medical texts or legal documents, financial data, or even ancient languages.
Oh, wow.
The potential for customization and targeted performance is just enormous.
It's like we're moving towards this world where we have a whole toolbox of specialized language models,
Yeah.
each perfectly adapted to a particular task.
That's a great way to put it.
Like going from a general-purpose Swiss Army knife to a set of precision instruments.
Exactly. And it raises an interesting question about where we're headed with language models.
Yeah.
Because right now, there's this big focus on building these massive general purpose models.
Right.
But as we develop techniques like what we see in Hymba, we might see a shift towards, smaller, more specialized models
Interesting.
that are incredibly efficient and tailored to very specific domains.
That would be a paradigm shift.
It really will.
Instead of one giant model trying to do everything, we have this whole ecosystem of specialized models working together.
Exactly. And it's not just about the tasks themselves, it's about making these powerful tools accessible to everyone.
Right.
So imagine a world where anyone, regardless of their technical expertise or their computing resources, can leverage these specialized language models to achieve their goals. Whether that's, analyzing complex data, automating tasks, or simply communicating more effectively.
That's a future I'm incredibly excited about.
Me too.
And it sounds like Hymba is really taking some major steps in that direction.
Absolutely.
But before we get too carried away with all these futuristic visions,
Right.
let's bring it back down to earth for a moment.
Yeah, you're right. It's important to remember that, Hymba is just one piece of the puzzle.
Of course.
The field of language modeling is constantly evolving, and there's still a lot of work to be done.
But even so, it's inspiring to see these kinds of breakthroughs happening.
Yeah.
It gives me hope that we're on the right track towards making this technology truly beneficial for everyone.
I agree. And what's particularly encouraging is that Hymba really demonstrates the power of innovative thinking.
Yeah.
It's a reminder that we don't always need bigger and more complex models to achieve really remarkable results.
Right.
Sometimes the most elegant solutions come from finding clever ways to combine existing approaches and really pushing the boundaries of what's possible.
Absolutely. Hymba is a perfect example of how ingenuity and a deep understanding of the problem can lead to some really groundbreaking advancements.
I couldn't agree more. Yeah, it really is a reminder that we don't always need bigger and more complex models to achieve really remarkable results.
Yep.
Sometimes the most elegant solutions come from finding clever ways to combine existing approaches and really pushing the boundaries of what's possible.
Absolutely. Hymba is a perfect example of how ingenuity and a deep understanding of the problem can lead to some really groundbreaking advancements.
I couldn't agree more.
So as we kind of wrap up our deep dive into Hymba, what are the key takeaways that you really want our listeners to walk away with?
I think the biggest one is that the landscape of language models is changing.
Okay.
It's not just about building larger and larger models anymore. Hymba really shows us that focusing on efficiency and clever architecture can lead to some remarkable performance even with these smaller models.
It's a real testament to the power of innovation, right?
Yeah,
Finding those elegant solutions that can really push the boundaries.
absolutely. And for our listeners out there who are really, the LLM experts, I think Hymba offers some really valuable insights.
Okay.
It challenges some of the assumptions of what a small language model can actually achieve. You don't need billions of parameters to get these state-of-the-art results.
It's like that classic story of David and Goliath,
Exactly.
where strategy and smarts win out over sheer size and power.
Yeah, that's a great analogy. And what makes Hymba even more exciting is that it's able to achieve this level of performance while also being more accessible. The fact that it performs so well with open source data and that it's highly adaptable through parameter-efficient fine-tuning opens up a world of possibilities for researchers and developers.
It feels like Hymba is setting a new standard for what we can expect from these smaller language models.
I believe so, and I hope this deep dive has inspired our listeners to think about the future of LLMs in a new light. We're really on the cusp of a really exciting era where these models are going to become increasingly integrated into our lives.
And Hymba, with its focus on efficiency and accessibility, is paving the way for a future where these really powerful tools can be used by anyone, anywhere, to solve real-world problems and unlock these new possibilities.
Well said. So as you go about your day, consider the intricate algorithms that are shaping the digital world around us.
Okay.
And remember that behind every line of code, every innovative idea, there are these passionate individuals who are striving to create a future where technology truly empowers us all.
That's a fantastic note to end on.
Yeah.
And with that, we'll wrap up our deep dive into the fascinating world of Hymba. Until next time, keep exploring, keep learning, and keep those questions coming. It really does feel like we're on the edge of something big with these LLMs.
Yeah.
It's really exciting stuff. And, speaking of exciting stuff, Hymba itself, obviously we've been talking about it this whole time, but
Yeah.
are there any specific examples or stories that really highlight, just how impactful this technology can be?
Yeah, one thing that comes to mind is the potential for personalized education.
Yeah.
Imagine a world where students have access to these AI tutors that can adapt to their individual learning styles.
Oh, no.
Identify their strengths and weaknesses, provide customized feedback, and really help them learn at their own pace.
Yeah, that's amazing.
And with Hymba's efficiency, we could make this a reality for students all over the world.
Especially those who, might not have access to traditional tutoring
Yeah.
or the best educational resources.
Exactly. It could really level the playing field.
That's incredible. It makes me think about, all the other potential applications out there,
Yeah.
things that we haven't even thought of yet.
Absolutely. I mean, this technology is still in its early stages, but the possibilities are really limitless.
It's mind-blowing.
Yeah, it is.
So as we wrap up our deep dive into Hymba, what's the one thing you really want our listeners to take away from this conversation?
I think it's this: don't underestimate the power of small.
Okay.
Hymba is proof that you don't need to build these massive complex models to achieve groundbreaking results.
Right.
Sometimes the most innovative solutions come from thinking outside the box, finding creative ways to optimize and adapt.
It's about working smarter, not just harder.
Exactly, and that's a lesson that applies to so much more than just language models.
Absolutely well said. And on that note, I think it's time for us to wrap up this deep dive.
Yeah,
I want to thank you so much for joining us today. It's been a truly fascinating conversation.
it's been my pleasure.
And to our listeners out there, thank you for tuning in. We hope you learned something new, and we hope you'll join us again next time for another deep dive into the world of cutting-edge technology.
See you then, Alyssa.